Good day, Bayaw. Today, we will be solving another problem from the book of Thermodynamics and Heat Transfer by Singal, Chapter 10, The Heat Transfer by Convection. Air at 25 degrees Celsius and 1 atmospheric pressure is flowing over a long, flat plate with a velocity of 8 meters per second. Determine the distance from the leading edge of the plate where the flow becomes turbulent, and the thickness of the boundary layer at that location. First, we'll be identifying our givens. We have here the pressure at 1 atmospheric pressure, the temperature at 25 degrees Celsius, the kinematic viscosity that is equal to 1.562 times 10 raised to negative 5 squared meter per second, its density that is equal to 1.184 kilogram per cubic meter, the velocity 8 meters per second, and the Reynolds number at critical point that is equal to 5 times 10 raised to 5. And here, we'll be finding the thickness of the boundary layer at the location of the long flat plate. Here is the solution. We have this equation of Reynolds number at critical point that is equal to the velocity times the distance of the critical point over the kinematic viscosity. So we rearrange the equation to have this equation of our distance at critical point that is equal to the kinematic viscosity times the Reynolds number at critical point over the velocity. So we plug in our values. We have here the 1.562 times 10 raised to negative 5 squared meter per second times 5 times 10 raised to 5 over 8 meters per second. And we have here the distance of our long flat plate at its critical point that is equal to 0.976 meters. Next, we will be finding the thickness of the boundary layer. We have here this equation, the delta x is equal to 5 times x, which is the distance over the Reynolds number at x raised to 1/2. So we have this, the delta at critical point that is equal to 5 x at critical point over the Reynolds number raised to 1/2. And we substitute our values, so we have this 5 times 0.976 meters over 5 times 10 raised to 5 raised to 1/2. We come up with this result of our thickness of the boundary layer that is equal to 0.006903 meters or 0.69 centimeters. And that's all.